So today we're going to be looking at simulations. Simulations can be one of the more challenging things in probability and statistics, more in the probability side. But we will be using the graphing calculator a lot for this. Now, make sure you're using the graphing calculator on your Chromebook, as the ones in the classroom, the steps aren't the same. So first and foremost, what is a simulation? Well, a simulation is a process of running trials using random numbers to find the probability of an event has happened. Side notes, you must have equally likely outcomes for the events. You also must have a key. Now, what a key is, well, in a simulation, it's all just numbers. It's random numbers. And you might know what the numbers mean, but if you give it to a complete stranger, they probably don't. So, you have to have a key. In other words, tell us what the numbers mean. Now, in your notes, the calculator steps are a tad bit different. So I'm going to have you guys fix this. Calculator steps, first we're going to go to math. And then we're going to move over to where it says prob, short for probability. And one of the first options there is one called randint, or random integer. Remember, integers are just whole numbers. And this is where your notes change slightly. Lower, cross out that 0 and make it a 1. We're going to make our lowest number that the calculator is going to spit out a 1. Cross out the 9 for upper, and we're going to make that the total number of options. And that's going to make more sense when we start going through some examples. And then our n, or the number of numbers the calculator is going to spit out, make that 1. And then for the simulation, then we go to hit paste and we hit enter. So let's look at the first example. Example 1. A cereal company is giving away a prize in each box of cereal, and they advertise, collect all 6 prizes. Each box of cereal has 1 prize, and each prize is equally likely to appear in any given box. Amanda wonders how many boxes it takes on average to get all 6 prizes. Now it says use the random numbers below to run a simulation, but having a set of numbers can be more challenging. Because if we skim through the numbers, we have zeros, we have 7, 8, 9. But according to the problem, we only care about the 6 prizes. We don't care about 0, 7, 8, 9. So because of that, I'm going to completely ignore the set of numbers and use our calculator. Now, in order to figure out if we can do a simulation, well, obviously we can because we're doing it. But in the problem, it says each prize is equally likely to appear in any given box. And it also says each box of cereal has 1 prize. So we know no matter what, each box has a prize, and we have an equal shot at getting each prize. So first and foremost, we need a key. So what numbers do we want to use? So I'll say numbers. Well, we're starting off at 1, and I need to know my max. Well, there are 6 prizes, so I'll say 1 through 6 are prizes, which is what we want. Okay. So we need to pull up our graphing calculator. On your Chromebook, You're going to want to hit the circle in the bottom left, hit the arrow to make it full, and start typing in TI-84, and your calculator should appear. My recommendation is to pin it, so 2-finger click it, and pin it to your shelf. That way you don't have to search for it every single time. Okay, I want to switch back and forth between some things, so here's our calculator. First step said that we have to hit math, which is right underneath your green alpha button. And then we're going to go over to prob, or probability. Now, it did say to go down to rand int, and notice on how the first one is just rand. We don't want that. We want rand int, or random integer. And we'll enter. Now, our lower number will always be 1. Our upper number is the number of options that we have. So there were 6 prizes, so 6. N will be 1. And we're going to go to paste. All right. So the goal that Amanda wanted to have in this problem was to collect all 6 prizes. So what she hypothetically does in this situation is she goes to the store, buys a box, opens it up, and then keeps track of what prize she got. She goes to the store again, gets another one, and repeats. So we can have numbers repeating. So we're going to, under trial 1, list out what prizes she gets. And we're going to want to make sure she gets all 6 prizes. So all I'm going to do on the calculator is hit enter. First number is a 6. And I'm going to underline it because this is the first time we got a 6. And then we hit enter again. So we don't have to do that whole entire process to get a new random integer. We can just hit enter. Next number is a 6. It's a repeat. So I'm not going to highlight or underline it. In fact, I'm using colors so they stick out. We're going to keep on doing this until we get all prizes. We have a 1. That's the first time getting a 1. A 4. A 3. A 5. Ooh, got lucky. So it looks like right now the only prize that we're missing is prize 2. So I want to keep on going until I get a 2. I have a 1, a 3, a 6, a 2. A 1, a 3, a 6, and then we got that 2. So we ran the first simulation, or the first trial. Which, side note, how many boxes was that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes total. All right, we're going to do this 2 more trials. Remember, always do at least 3 trials. So you can hit clear and clear your screen, and then you can continue hitting enter. So we have a 5, a 6, 2, and a 3. Got real lucky to start here. 5, 6, 2, a 3. A 1, a 6, a 1. So 1 is new. 6 is a repeat, and that 1 is a repeat. It looks like the only one we're missing now is prize 4. So a 1, a 4. So a 1 and a 4. Okay. So how many boxes was it this time? Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And one more trial. I'll hit clear. We have a 6, a 6, 2, a 2. So we have a 6, and then we got the same prize. Then we got a 2, and then the same prize. A 1, a 1, 5, 1. So 1 is new. Next one was not. The 5 was new. And then we got a 1 again. Looks like we're missing a 3 and a 4. Oh, there's our 3. So a 3, a 2, a 6, a 1. So 3, 2, 6, and a 1. Still missing that 4. 6, 4, there it is. 6, and then 4. So then how many boxes did it take? Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 this time. So then we need to figure out, because she said on average, how many boxes did it take? Well, we ran 3 trials, so I'll add up all 3 numbers. So 10 plus 9 plus 14. And divide it by the total number of trials, which would be 3 in this case. By doing so, we can say it would take, on average, 11 boxes. Okay, let's look at example 2. Example 2 says your teacher is invited or has invented a game called 3 Rolls to 10. You roll a fair 6-sided die 3 times. If the sum of the rolls is 10 or greater, you win. If the roll is 10 or is less than 10, you lose. What is the probability of 3 rolls to 10? Use your random number generator on your calculator to help. So once again, we need a key. So what numbers can we use? So numbers 1 through, well, in this case, what we're talking about is a 6-sided die. So on a 6-sided die, the numbers that we have are, well, 1 through 6 are rolls. Okay. And unlike the last one, where we wanted to know how many boxes it would take, in this one we know how many rolls we can have per trial. There are 3 rolls that we can have per trial. So, we are going to go into our calculator. I want to clear out that screen to make it nice and pretty for us. So we're going to go to math, over to prob, and down to rand int. This time our lower number is still 1. In this case, our upper number is still 6. And we'll still make n 1. I'll go to paste. So even though the numbers did not change, I would still recommend going in for each problem. Now this one differs because I could just hit enter 3 times right now, and there's our first trial. 1, 2, 3. So we ended up rolling a 2, a 6, and a 5. And what we can do is we can just run all of the trials first and then talk about what they mean. So I want 3 more. So 3 enters, a 2, and a 6. Clear, 3 enters, 6, a 1, and a 1. That 3 more times. Remember, at least 3 trials. 5, a 6, and a 4. A 2, 1, and a 6. And 1 more trial. A 2, a 3, and a 1. Okay. So in order to consider a win, the number has to be a 10 or bigger. So the numbers have to add up to 10 or bigger. Well, in the first one, it adds up to 13. So in this case, yep, they take the W. They win. In trial 2, a 2 plus a 2 plus a 6 gets us 10. And it says if the roll is 10 or greater, so we just barely won in trial 2. Trial 3, a 6 plus a 1, a 6 plus 1 plus a 1 gets us 8, so we took the L. Trial 4, well, 5 plus 6 plus 4 gets us 15, so that is a win. Trial 3, 2 plus 1 plus 6 gets us 9. Oh, so close. Still an L though. And then trial 6, real bad rolls. 2 plus 3 plus 1 gets us 6. That is an L as well. So we need to answer the question, what is the probability of winning 3 rolls of 10? So the probability of winning is, and since we're talking about a probability, it is always a fraction, success over total. Well, our success would be winning, and we had 3 wins out of 6 trials. So it'd be 3 out of 6. Let's look at example 3. Example 3 is a 2-part. It says a beach resort makes most of its money during spring break. To make money, it needs to not rain at least 4 days out of the 10 days. Based on the weather forecast, there is a 1 out of 5 chance that it will rain each day for the 10 days of break. Design a simulation that would model the weather for 10 days of break. So, key. This key is going to be slightly different. We still need to know numbers. But first, we need to talk about what we're talking about. Looking at it, we're talking about a hotel or a resort that wants to make money. And things that could happen is, well, it could rain or it could not rain. So I want to talk about that right there, that fraction. That fraction, the 1/5, is actually super important. Because it's not just a 1/5, it's saying 1 out of 5. So actually, that 5 tells us the range of numbers that we are going to use. So the bottom of a fraction, in this case, when it's talking about a fraction chance, the bottom of the fraction tells us the number of numbers we are having to use. Now, we could say numbers 1 through 5 in this case, but that 1 through 5 has 2 options. 1 through 5 would either be dealing with rain and not rain. So, that top number tells us how many successes, just like a probability. So that means one day it will rain. So it says there's a 1/5 chance that it will rain. So one day means rain. So we get to decide what number we want to be rain. Easy choice, 1. So 1 means rain. So if 1 means rain, then the numbers 2 through 5 mean no rain, or the complement. Okay. The other things that we need to pick out from the words. First, it says 10 days of spring break. Like I will talk about this 10 days of break. What that tells me is that we have 10 days total in break, so we need 10 numbers per trial. So pull up your calculator. I'm going to hit clear. So we go to math, over to problem, down to number 5, the rand int. Lower will forever be 1. Upper in this case is not a 6 anymore. It's the 5 because that's the bottom number of the fraction. I'll go ahead and paste and hit enter. So each trial needs 10 numbers, so I'll hit the calculator or hit enter 10 times. You have a 2, a 5, a 2, a 3. A 4, 1, 1, 1. A 4 and a 4. And let's just get the numbers for all of the trials first. And then we'll talk about what they mean. So now I need 10 more numbers. So 5, 2, 1, 3, 5. 4, 3, 4, 5. And one more, 4. And one more trial. Oh. 4, 3, 2, 2. 4, 5, 1, 3. I have 8, so I need 2 more. 3 and a 2. Okay. So we have our numbers. Reading more of the problem says to make money, it means to not rain at least 4 days of the 10 days. So 4 of the 10 days have to be not a 1. So looking at our trials, I have a 1, 2, 3, 4, 5, 6, 7. So 7 of the 10 are not right. So because of that, yes, they make money. Trial 2. Once again, at least 4 days of the 10 needs to not rain. So not 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. You had a really good trial, that one. 9 out of the 10. So, yes, they made money. And then last trial, another good one. Another 9 out of 10. Yes, they made money. So in this problem, there is no real question that is being asked of what is the probability that they'll make money. So we can actually leave this one here as long as we have the key, check, and at least 3 trials.